All right, welcome to the third video of week 3, and this is where things get a little bit more tricky. So you are going to be learning today how to apply oxidation states and how to determine if a reaction is a redox. So has it gained or lost electrons? In order to do that, I need to teach you a few things and a few simple rules so you know what to look out for before we actually go into the practice of this. This video is going to cover most of the practice. I don't really want to go over definitions. You can see the definitions over here. You can read them. I will repeat oil rig to you because this is just easy. So we're going to look at the oxidation number concept, oxidation and reduction. So oxidation, you guys should be aware of oil rig. Oxidation is loss of electrons and reduction is gain in electrons. It's really common to mix these up, so I would just write oil rig the moment you get your paper. Oil rig, oxidation is loss, reduction is gain. Now, I've got a quick table here that gives you a general idea of how to summarize these things, and this should really help you. You don't need to remember the table off by heart, but it gives you some rules and principles that I'm going to help you out with. So an uncombined element or something by itself is going to be 0. So if you can see here, oxygen, hydrogen, Fe, and S8. Oxygen bonded to itself, 0. Hydrogen bonded to itself, 0. Fe on its own, 0. S8, this is sulfur as a molecule, bonded to itself, is 0. We keep that nice and simple. Hydrogen, or in almost every scenario that you'll encounter, if hydrogen is bonded to something, it'll be +1. So you can write a +1 where hydrogen is, and you'll see when I do that. So over here, H2O. You can see here, there's hydrogen, there's 2 of them, so it's 1 plus, 1 plus, 1 plus. So hydrogen provides 2 plus to this molecule. There's no charge, so therefore oxygen must be 2 minus. And I'll explain the rules for that too. Let's have a look at ammonia. There's no charge, so it's neutral. Hydrogen, there's 3 of them. It's going to be 1 plus, 1 plus, 1 plus. Therefore, overall, it's 3 plus, which means nitrogen must be 3 minus. And therefore, that's how we do this. So I'm going to go over this quite a few times, so don't worry. But the general rule is hydrogen's just going to be 1, which is quite easy to remember. You can see the exceptions here, and we will cover those when we encounter them. But for now, we don't need to worry. Combined oxygen. So like I said over here, with oxygen, it was -2. And it's still going to be -2. So we don't need to worry about that. If you see oxygen, it's going to be 2 minus. And I'll show you the trick to be able to remember that too. Halogens, so this is your fluorine, your chlorine, your bromine, your iodine. These are all going to be 1 minus. So if you have a chlorine bonded to something, that'll be 1 minus. And you can see here, this proves it. Hydrogen, even if we do the hydrogen, this is going to be 1 plus, which means fluorine must be 1 minus. Let's do it the other way around. Chlorine, it's in group 7, so therefore it's 1 minus, which means hydrogen must be 1 plus, and that holds true. And then you can do the same for HBr, you can see. Lastly, ions. If you see an ion, it tells you what that charge is. So you'll see a slight positive or a negative superscripted over here and here. This tells you what is the charge of that molecule of that ion. In Na+, the charge is 1. In Mg2+, the charge is 2. In La3+, the charge is 3. Now, one thing you may notice the pattern with is if you look at the periodic table, which I should have here, typically the group that it's in will tell you the charge. Hydrogen is in group 1, so that's going to be 1 plus. Magnesium, calcium are in group 2, so when they form or combined, they'll be 2 plus. We'll do this big skip over here. Then we've got aluminium is in group 3, so that will be 3 plus. Carbon's a bit of a weird one, and that could be 4 plus or 4 minus. Now we're getting on to the other side. So nitrogen will be 3 minus. Some of you might be thinking, okay, why is it not 5 plus? The reason being is we're trying to complete the 8 octet rule, the 8 outer shell. So what is easier for nitrogen to do? Is it easier for it to gain 3 electrons, or is it easier for it to lose 5? It's easier for it to gain 3. If it gains 3 electrons, it's being reduced. Therefore, it becomes 3 minus. Oxygen is in group 6. In order for it to get to 8, we need to add 2 electrons. That's a reduction. So therefore, we go 2 minus. Fluorine, group 7, 1 minus. Helium, these are already at 8. So you can see over here, they'll be neutral, 0. And that's a general rule that is going to be able to work for most of these. We are going to put it into practice today, so hopefully you'll get a better picture of it. But for now, knowing these rules and coming back to them is perfectly fine to use them whilst you're still practicing. Now, I'm going to take you through this one here at the top, and then I would like you guys to complete these ones down here. They will take some time, they will take some practice, but once you get this skill, you're looking at 4 to 6 marks depending on the paper. So assign oxidation numbers to the question. So the questions come up, you're in your exam hall, they give you this. Oh my God, what is SR? What is HCl? What is going on with my life? I don't know what to do. I don't know where to start. So let's start by identifying the things that we do know. What has happened from going from one side to the other? And this is how we're going to prove if it's a redox. So from SR, is it on its own? Yes, it is. So therefore it must be 0. You can even find it on your periodic table. It doesn't matter where it is at this moment in time, but it's going to be 0. Now, the next time it appears is over here in strontium chloride. So I'll go from here to here. Over here, what's happened to it? Oh, it's now bonded to chlorine. What do we know about chlorine? Chlorine, when it's bonded, is -1. So that's 1 minus, 1 minus. We've got 2 of them. It's 2 minus overall. There's no charge here, which means SR must be 2 plus, which means we've lost electrons. So therefore that is an oxidation. Let's have a look at the next thing. The next thing we produce over here is hydrogen. How was hydrogen before? Hydrogen was bonded. Let's do this in purple. So hydrogen from here to here, what's happened to it? Over here, hydrogen is unbonded. It's on its own. It's 0. Let's have a look on the left-hand side. Again, I'm using this arrow as a divider. Over here, it's bonded to chlorine. Chlorine's in group 7, so we know that this is 1 minus, which means there's no charge, which means hydrogen must be 1 plus. If I go from 1 plus to 0, what have I done to that number? I've gained an electron. I've reduced the number. That's where that reduction comes from. So it's a reduction. In this reaction, from going from this side to this side, has there been a reduction and an oxidation? Yes, there has been. Therefore, yes, it is a redox, and that is how we show why. One last thing I wanted to show, and I'll do this in green, is something we call spectator ions. So this is where nothing happens. They just watch the reaction. They don't change, they don't gain electrons, they don't lose anything. Sometimes you might be asked about a spectator ion. Now, the only thing we've not talked about is that chlorine. So chlorine, what happened from chlorine from here to here? It went from 1 to 2. The equation's balanced, but let's have a look at the charges. Chlorine, when it's bonded to something, we've said it's 1 minus. Let's go over here. Chlorine is bonded to something. It is 1 minus, but the other one's also 1 minus. So I'm going from 1 minus to 1 minus, not 2 minus. Both these chlorines are 1 minus. They haven't changed. There's no redox here for them. So they don't reduce, they oxidize. Therefore, Cl is a spectator, which apparently I can't spell under pressure. Oh my God. Spectator. There we go. So chlorine's a spectator in this example. There's no change. What I would like you to do is to engage in that same type of analysis for these. Remember the rules I said before. H is going to be +1. Chlorine's going to be -1 because it's in group 7. Magnesium, when bonded, it'll be in the group number that it's associated with, and you can apply that all the way through. Right, I'm going to leave you to this. I'm going to move on to the next section over here. This is oxidation numbers. Please complete that previous section before you do this, because otherwise you will get confused. Okay, so oxidation numbers. The big jump I talked about before, this big D block right over here, these are transition elements. All the ones on the left, metals, these are going to have the same oxidation state. 2 plus, 2 plus, 2 plus, 2 plus, 1 plus, 1 plus, 1 plus, 1 plus. Or even over here, 3 plus, 3 plus, 3 plus. However, the transition metals, the D block, these can have varying numbers. They can have different amounts. So the rules don't really apply to them. So for example, iron, when we look at over here, that could be 2 plus, and 1 plus, and 3 plus. But it depends on what it's bonded to. So that's why we need to know the rules from before. Iron can exist with a number of 2 plus or 1 plus. Therefore, the number is now given in brackets. So you see iron 2 chloride. That means we have an Fe2 plus chloride. In order to balance that, we need 2 chlorides. So that must be Cl2. And that is how that is going to work. The next examples are going to be using these numbers. So make sure you're clued up on the ones before you have a go at this one. I'm going to scroll down and I'm going to introduce one last thing. I'll just tell you now, I'm not going to teach it you, but I will tell you, just learn these. SO4 2 minus, SO3 2 minus, NO3 minus, NO2 minus. I just say it over and over and over again in my head, and this will save you from having to learn this bit. This bit, I promise you as a chemist, going to make your life a lot easier if you just learn them. When they come up, you know what they are. They stay together. I'll cover that in a bit more detail, but for now, let's move on to these. So, this is a mess. I think I've lost all my shifting. Let's clear that out. Unfortunately, they're not their answers. It's just moved from when I've looked at it in the past. So let's have a look at completing the following. So I'm going to do this one with you first. And what we need to know is, can we show which element is reduced and which is oxidized? So it's no different from the task before, but now I'm just introducing some of the metals. The first metal we look at is a alkali metal. It's an earth metal. Sodium, it's in group 1. It's going to be 1+. So it's dead easy. And that's why I'm going to do this one, and you guys can do the other ones. So for sodium, chlorine, sodium chloride, the question to ask is, what's going on from left to right? I'm going to be random. I'm going to pick chlorine. So when I go from chlorine here to here, what's happened to chlorine in terms of its charge? Over here, Cl2, it's bonded on its own, so therefore it must be 0. On the right-hand side, it's now bonded to something. It's bonded to sodium, so therefore it must be 1-. It's in group 7. It needs 1 electron. It's reduced. So my answer over here is chlorine is reduced from 0 to 1-. That must mean sodium has been oxidized, but let's prove it. So sodium goes from over here to over here. I like to draw the arrows, it makes my life easier. Sodium is unbonded, so therefore it must be 0. I also know that when it's bonded, it's in group 1, so it must be 1+, but let me just prove that. Chlorine is 1-. This is neutral, there's no charge here, which means sodium must be 1+. It's gained oxidation, so therefore it's been oxidized. So therefore we go, sodium has been oxidized from 0 to 1+. Is this a redox? Yes, it is. Really simple. This is just more practice, but now we're going to look at transition metals. I would like you to do the same analysis for these, and using the table from before, remember that these guys come together, so they stay together, those SO4s, and this one's just oxygen. Have a go at this, and hopefully enjoy.